Welcome everyone to another fun Linux live stream. I noticed this regression, to today's topic. Linux regressions, obviously a recurring theme here, programming in C and stuff. We got that, and testing and letting the users test. I actually noticed this already the other day. Actually during a live stream we were building Firefox, and that took like really long, especially debugging that, compressing, because usually I build with TempFS here, our fine little source distribution ZSTD2. And so usually TempFS for extracting the sources, like blazing fast here on Epic thread-ripping Ryzen stuff in memory, DDR4 speed obviously, hopefully soon DDR5, certainly that beats any other further longer distance, slower PCIe connected storage. Anyway, so yeah, TempFS like you would be doing for high performance stuff. And for debugging, the issue is with TempFS, with our build system, at the end of the build, its unmounted data is gone. And this is why for testing purposes, I built, for testing and then debugging, patching purposes, I built in then not with TempFS, and that was super slow, like really slow. We were literally waiting here live on this other live stream of Firefox stuff, and that took like forever. And today I tested quantitative how slow. I actually made here a poll like recently, Firefox update, and I guesstimated. So my guesstimate is like it felt super slow, right? Like extracting the sources is like it took forever. And I guesstimated 10 times, and hey, even my guesstimate was wrong. It's 20 times, like 2000% or whatever that is. And I quickly tested. So also I was like, I'm really getting tired of fixing other people upstream regression, because I said this so many times, in my opinion, among other, certainly a lot of things why we don't have the year of Linux list, but one thing is that also even annoys the heck out of me as a developer, this constant API changes in Linux. Like the Linux developers say for a long time, like, yeah, we make it the most amazing. This is why if we want to change something to make something better, we just change it, breaking and more breaking, at least in not user space, ABI or API, but in kernel space. And Marco writes, too much frustration. And so this is 20 years later, right? People always wonder, why am I here so negative, right? I'm doing this Linux stuff for 20 freaking years. And in 2020, you update to the latest and greatest kernel, that is 5.10, and your file system I/O becomes 20 times slower. I tested this shortly. Instagram, if you want some cooking photos and sometimes some raw snapshot. I posted this here because I had to reboot. Yes, I could have made a screenshot, but yeah, the year of Linux desktop, right? Screenshotting here on Wayland. Anyway, so these are the numbers. So this is the performance that I usually get of what you see here live of tarring. So this is just tarring, archiving this tar, extracting here without any other stuff. So this is without caching, 16 seconds, which is quite okay, right? This is an external SSD here. My previous video actually aging super slow, USB 3 Gen 1 Samsung T3, or I shouldn't touch it too much, not that deep touches. So anyway, 16 seconds, that is with 5.9.15. And when it's cached, like, then certainly that reduces a little bit from 16 to 14.6. So 14.6, and you see this here. You have seen this for many years, for many months, if not years here, if you're a regular on this channel. So how slow is this with 5.10? It's nearly 5 freaking minutes. You can't even make, you need to like, 4 minutes, and it's mostly I/O wait, so, and it could be multiple things. So how to tackle this, and according to my question here, I only wanted to make a brief summary. I'm somehow probably not bisecting this. As Linus Torvalds gets enough $1 million, he probably can do that himself. I probably continue now some nice low-level code here. I even ask, like, should I bisect this, like yes, no, and but your microkernel is like, yeah, exactly, but my microkernel. If I continue fixing each PS3, also previous 4.9 broke PS3, 5.9 broke PS3, 5.10, it's like, yeah, you BTRFS. This could be multiple things, so it could be downhill, it could be just BTRFS, could be IO scheduler, could be I run this with full disk encryption. However, some data point, so this is, which kernel is it here? By the way, I think I rebooted though. Yeah, I rebooted because this kernel was just doing that. I have here just as a data point, how fast is that? Do I have here something? So this is a brand new, also, so this is a brand new, just a couple of 100 megabytes, like literally unpacked yesterday and first time used today. Brand new PCIe 4, 1 terabyte NVMe SSD, video coming soon. And so what is the performance difference on a proper kernel, like properly working kernel without freaking crazy regressions like 5, 9, 15, compared to USB 3 Gen 1 externally attached dongle thing. Let's do that again, also with a little bit of performance waste. This should be like half. I've done this, actually this, yeah, so 6 seconds. So this is the performance just as reference. So, and also, I don't think it's entirely USB. So this is just performance reference. How much performance are we losing between externally connected Samsung T3, I think, USB 3 Gen 1 SSD. In the cache, we can, by the way, do this again, although right now we should at least RM that again. Also, yeah, so this leaves the cache a little bit dirty, the buffers and whatnot. Theoretically, probably a little bit. Let's do that again. But this is also how I timed this. Of course, not the super most scientific, just ballpark numbers here. And so cached, yeah, a tiny little bit. So yeah, 6.1 versus 14, so twice as fast. Again, so this is on a properly working kernel. I have done the same. So I think probably it's mostly, so it's not, I made already 2 tests with 5.10. It's not Luke's crypto full disk encryption. I've, for this reason, used this NVMe here today with 5.10. So this is 6 seconds, right? With, unfortunately, I think I didn't make a photo as per usual. Screenshotting here with super professional. No, I didn't. It was 34 seconds. From my memory, so this would be 34 seconds. So 5.10 on the external, not external, 5.10 on the internal PCIe 4, brand new 1 terabyte, high performance, like 4 gigabyte or something per second, video soon. 34 seconds from 6.1-ish. That is still without the USB 3 stuff. It's like, yeah, it's crazy. And this is the development. Also, I lived through, what have we lived through here in 20 years of Linux? GCC 2.95 to GCC 3, major regressions all over the place. I mean, not to mention Red Hat's broken GCC 2.96 back in the day, for those who remember that amazing time. Then glibc 1 to, I think, yeah, glibc 1 to glibc 2, major breakers all over the place. Then, of course, thread local storage and whatnot, and glibc major breakers all over the place. Then we had this DevFS, because static device node certainly not the future. Of course, the Linux kernel developers disagreed, and DevFS always was the black swan there, and certainly nowadays deleted, replaced with UDEV in user space, because not everything in one address space monolithic kernel. So UDEV and this stuff, and then systemd. So the only constant in Linux desktop apparently regressions and changes, and probably also why we don't have, among certainly a lot of other things. So you have Linux. So yeah, so super frustrating. So I mean, given, so how would we debug this? The good thing is you don't need full disk encryption for this 5 to 20 times performance marginality regression here. So I probably could bisect this. I'm somewhat like, yeah, probably maybe in 1 hour we could nail this down. Maybe I actually should, for the fame of it, of sending patches upstream. Because how would you tackle this? Of course, super time wasting with, have you tried to switch it off and on again, rebooting this here. So of course, in 2020, bisecting this, of course, with QEMU virtualization. So run boot the kernel with QEMU in a loop, like bisect, start good and bad, and then QEMU, like build kernel, make VM Linux, initRD stuff, and fully automate this in a loop and test the timing and automatically, because otherwise super annoying to sit here an afternoon of manually measuring the performance. Maybe, yeah, if this regression, maybe I would hope someone from Oracle or IBM eventually figures that and fixes that, because honestly I think I have a microkernel to write. But yeah, otherwise fully automate this. Maybe one day, if this regression lasts longer, maybe I do in another live stream. This basically is just a summary of, I'm not making this stuff up, that is actually really real like that. And for you, another data point of USBs, regen 1, even not that bad. PCIe 4, SSD 4, at least for this use case. Certainly there might be other database, whatnot, for even higher I/O load, but this tar bombing the source code on a BTRFS, it's like, yeah, 14 versus 6 seconds. It's like, probably we can live with that. And for me, if you wonder why do I even do this, I said this 100 times before, for me, portability. I can leave this monster of a overkill workstation, previous video with previously 3950X, now 5950X video coming soon, and sneak peek yesterday on the MoLive channel. I can leave this in the office, certainly not carrying a tempered glass case here with me home and stuff, and just plug out the SSD, plug it in at home, and have like everything. Sure, you can do this with cloud computing and stuff, but it's always a difference between having some data in your cloud cluster file system stuff and having like you who will like everything, not only one project and whatnot. This is why. Anyway, so yeah, USB, that is a performance, PCIe 4, and some sneak peek and mentioning of other stuff. Actually, yeah, so that's it for that video. Leave in the comments below. I had this questionnaire. You can still vote on that here. Right now it's like 38% yes, so probably if I should actually, like a democracy, do what, like, yeah. Anyway, I'm actually longing, you probably from my frustration with this regression heard it and guessed it already, longing for my microkernel and more usable code base. And if that would be my kernel, I would actually have at least some little bit of automated testing in place and not release random, ever-changing, constantly changing stuff. Anyway, let's see, what do we have there? Old School says T2 is great, leave Linux to my frustration. Yeah, Marco, wondering what is Marco running? Are you still running Linux, or Marco is also hyped for microkernel stuff. And for me, this is also, but again, with previous videos, if we invent, certainly others have already, but if we implement super high performance ring buffer based high performance IO, like similar to Linux IO ring, maybe the performance could even match single address space monolithic kernels with enough time and money on that, which somehow I neither have time nor money, but you can share, like, and subscribe to change that. Certainly there are microkernels, QNX, L4, and but I would not even say macOS is a microkernel with they don't use much of the Mach microkernel, which anyway was the slowest. They have basically mostly one huge BSD task running in their Mach microkernel. So yeah. What else do you have? Linux kernel break things, so Red Hat can maintain old versions, backport needed changes, and says Dr. Schubert. Yes, it's also like, it always was. It's of course not by Linus Torvalds, not a commercial offering, and somehow of course the open source stuff is always like, you get free stuff, feel free to test it at home, you got it for free anyway. So yeah, have fantastic. The Gravas is spinning, extracting Firefox. 32 seconds on, 510 on, so 35 on a spinning disk says, so yeah, a spinning disk 32 would be, this number would be similar to that of my SSD, right? So I already checked, but I didn't change the config really much. It could be simply something like not detecting SSD mode, because if you do we have here SSD, this BTRFS has here some SSD optimization mode. I could actually reboot this. I didn't check that in the log, but it could be that maybe the new kernel does also not detect it's an SSD. But 5 minutes is of course super crazy. Your 32 seconds which is also, is most stuff still dirty, not yet flushed back to the disk. Yeah, but 5 minutes is of course super crazy. That of course a USB 3 attached, as you see, performance not that much worse, only half than a PCIe 4 attached NVMe. Should of course not take 5 minutes, and previously it took only 14. And I diffed already the config. Do I have here? Yeah, it's even in the history. So I already checked here a little bit, scrolled over, nothing particular stood out. It's still the same IO scheduler. This preemptive I only changed recently last night. This sure should also not quote that. And the preemptive was only after the live stream, so the first live stream was also really slow. Also this max CPU thing I only increased yesterday, because I thought if someone takes T2 on the latest and greatest Epic or Threadripper, then probably they want more than 32 CPUs. That also this energy module only because last night I did some other unrelated performance testing. So otherwise only some noise here and there. IO scheduler was the same, but yeah, config change is not the greatest. Anyway, the Graver says, I certainly saw this, but this is 4.9. I can boot back in 5. I did not want to live stream with a potentially somewhat performance marginally regressing kernel. Marco says drop Linux. So the thing is, I said this as a live stream, of course I will continue maintaining T2. We will see and certainly improve macOS support and so on. But this is also the reason why the last 10 years I didn't use it for the desktop. I also said this before. Even with all my T2 Linux and enjoying all the different platforms from ARM to Spark and PowerPC and stuff. Even I was using, like other major developers at Red Hat and SUSE and Oracle and stuff, mostly macOS on the desktop, especially as we has. Although this only happened because we had this macOS retail products as seen here previously. And due to that, otherwise, if we would not have had that and before, so actually, unlike other SUSE and Red Hat developers, before I was fully using Linux on the desktop from 1996-ish to 2000. So the first 10 years I was using actually my own T2 Linux. At that day, also KDE and GNOME were better maintained and updated. Only due to the increased business of our Mac software, I actually started to use that on the desktop for the last 10 years and now transitioning back. And you obviously have seen the updates at even GNOME and KDE, also not yet perfect, vastly improved, but I would also honestly not use KDE or GNOME in my commercial business daily desktop, which obviously it's also a pity 20 years later. Yeah, with that, I will of course continue maintaining that and also improve the automation. Maybe actually this kind of thing are actually the things I sometimes do at night, you know, when Junior and wife are sleeping already and stuff, and I wait for the last change of diapers before midnight or stuff, and have there an hour or so, then secure shell to the office and script, do some T2 updates, some bug fix here or there, script some performance testing, just the regular life thing. The Grever says, yeah, 5 minutes is complete bonkers. Yeah, and this I immediately noticed, or sort of immediately on the other live stream, right? When this is Firefox, latest Firefox, the usual stuff. And when I updated this, I was like wondering why the heck does this. 84 is the latest version, right? I start to lose overview a little bit. Anyway, which key command also was not super. Oh man, something of that sort. You get the idea. Was this not super wee? No, this was tab. Whatever. Use the tiling window manager. It's amazing. This hit. Yeah, it's total bonkers. Maybe the problem is if the Linux kernel developers would accept patches faster, I would actually BSect this now. But I sent in the QLogic fiber channel stuff, took like sending it in 4 times. I sent in some SGI Octane QLA 1280 print K regression fix, no comment. I set standard compressed firmware loading, no comment. I even sent in a version 3 the other day, no comment. And in my opinion, this is also super. I said this before. This is, in my opinion, pretty disrespectful for community contributors like my unsuccessful one-man contribution here. The big kernel people that get a 6-digit salary from IBM, Oracle, and stuff, or the Linux Foundation should at least reply, no, not interested, or fix that and that. For me, it's like, yeah, I do the stuff here, send it in, and then nobody cares even. Why should I even do this and fix other big business, IBM and stuff? But yeah, as this performance is totally bonkers. Anyway, that's it for this video, and yeah, so T2 maintenance will continue, but also microkernel. I'm still realistically, given that I don't have endless time, maybe I should actually start to copy and steal other microkernels stuff to make faster progress, but we will see how we continue with it. Anyway, cheers. Thanks for watching. Hope you learned something. Don't forget to share, like, and subscribe. And I hope to see you soon for whatever we do next. And as usual, when we end the live stream, most people are watching, but that's it, as usual. But even without the SSD optimization, I don't think this, as usual, I say, have a good day, and I continue. I would, by the way, say, why is he what have we done? Kernel Git, was he not previously? Why does this look so strange? Oh, this is architecture. How did I click on that? Is it even, wait a second, why is this 359? I wonder if we directly could guess something just looking at that. But yeah, even that source is not the smallest. Yeah, just staring on that, we will not find this. It is just too much stuff. You would probably, this is why you would usually BSect this. But even for not SSD optimization, I think the performance should not like be 20 times slower, even if it's probably not that easy. But anyway, looking forward to your comments. Share, like, and subscribe. And as you see, the more you share, like, and subscribe, and